Can we actually refreeze the Arctic? I mean, it sounds like something straight out of a sci-fi movie, right? A last-ditch, desperate plan to save the world. But here's the thing. As the Arctic melts faster than anyone ever predicted, some scientists are asking this question for real. The idea is, well, if we can't stop the melting, can we manually step in and rebuild the ice? It is an absolutely massive, audacious plan, and we're about to break down exactly how it would work and all the things that could go horribly wrong. Okay, so to really get this, our story starts here. Picture this. We're in the far, far northern Canadian Arctic. It is just a vast, white, frozen world. The temperature? A bone-chilling -26 degrees Celsius, with this haze of tiny ice crystals just hanging in the air. This is the front line. And right here, a small team is testing an idea that could literally change everything. Or, it could backfire spectacularly.
So why are they even thinking about doing something this extreme? Well, to understand their mission, you first have to grasp the incredible scale of the crisis they're facing. The Arctic right now is caught in what scientists are calling a death spiral.
And look, this is not some far-off, distant future problem. It's happening as we speak. Think of the Arctic as the entire planet's air conditioner, and right now that air conditioner is breaking down. The winter right before this experiment took place was the warmest one in 75 years, and it shrunk the sea ice down to its smallest size ever recorded.
This kicks off a really dangerous self-perpetuating cycle. So think of bright white sea ice as this giant mirror that reflects something like 90% of sunlight back into space, keeping the planet cool. But when that ice melts, it exposes the dark ocean underneath. And that dark water, well, it's like wearing a black t-shirt on a hot sunny day. It just soaks up the heat, absorbing 90% of it. So more heat means more melting ice, which means more dark ocean is exposed, which means more heat gets absorbed. You see where this is going? It's a feedback loop, and it's putting global warming into overdrive.
So, with the situation being this dire, we're starting to see some truly radical ideas pop up. The main concept here is a type of geoengineering, and it all boils down to one wild question. If nature can't rebuild the ice fast enough on its own, can we step in and give it a helping hand? And that brings us to the key players, a UK company called Real Ice. Now, their goal isn't just to make more ice, it's to make thicker, more resilient ice. Ice that's strong enough to actually survive the 24-hour sun of an Arctic summer. The hope is that if they can pull that off, they might just be able to interrupt that devastating melt cycle. This quote from the co-founder, Keon Sherwin, it really captures the feeling behind this whole project. It's not some triumphant, "we found the solution" kind of statement. It's a somber acknowledgement that we're probably way past the point of easy fixes. This is a plan born out of pure necessity. So, the billion-dollar question. How exactly do you rebuild sea ice in one of the most hostile environments on the entire planet? Well, the method itself, it's surprisingly simple. It really just comes down to 4 basic steps. The team finds a good patch of ice, they use a big electric drill to punch a hole right through it all the way down to the ocean. Then they drop a pump into the hole. And finally, they just turn it on and flood the surface with that frigid seawater, which, as you can imagine, starts to freeze almost instantly. And you can see it happening right here. After they drill that hole, the result is this huge pool of seawater that just spreads out across the snow-covered surface. It creates this giant slushy mess that's all ready to freeze into a brand new, thick layer of ice. And here's the crucial part. It actually works. After doing their experiments in the winter, the team came back in May to measure the results. And get this, where they had pumped, the ice was nearly half a meter thicker. We're talking 1.9 meters compared to just 1.44 meters on the untouched spots nearby. That's a huge increase, and it could be the difference between that ice melting away completely or surviving the summer. But, and you knew there was a but, whenever you try to intervene in a massive natural system, there are always serious risks. There are potential downsides. And this is where the story gets a whole lot more complicated. Okay, so here's the first major trade-off. When you flood the surface, you're covering up the snow. And snow is amazing. It's a brilliant reflector, bouncing back 90% of sunlight. The new, bare ice you create, it only reflects about 50 to 70%. So if new snow doesn't fall pretty quickly to cover it up, you could actually end up absorbing more heat than you did before.
And there's another problem, salt. When seawater freezes, it pushes the salt out, creating these pockets of super salty slush on the surface. Now, think about what we put on icy roads in the winter to melt them. Salt. It's the same principle. This salty brine can lower the freezing point of the ice around it. So the big, scary question is, could this process, ironically, end up accelerating the melting come summertime? And beyond all the physics and the chemistry, there's the biology. That layer of snow they're flooding isn't just some empty space. It is a vital habitat. It's a nursery. Ring seals dig out little layers in the snowdrifts to protect their pups. Polar bears dig dens deep into the snow to keep their newborn cubs warm. Flooding the surface with seawater essentially paves over the nursery of the Arctic.
So, despite all of these challenges, the team at Realize is not thinking small. Their ultimate vision for how to scale this project up is, well, it's straight out of science fiction. Their ultimate goal is to thicken 1 million square kilometers of sea ice. Just to put that into perspective for you, that is an area roughly the size of Texas and New Mexico combined. It's staggering. And how would they possibly do it? Well, not with people out there on snowmobiles. The plan calls for a massive fleet of 500,000 autonomous underwater drones.
Oh, and the price tag for an operation of this scale is just as mind-boggling. We're talking about an estimated $10 billion every single year.
Now, it's really important to remember that this entire grand vision relies on technology that doesn't even exist yet. These drones would have to navigate under the ice, melt their way up through it with some kind of heated pipe, and then start pumping water, all while being monitored from thousands of miles away. It's a huge technological hurdle. Which brings us right back to this powerful quote from the co-founder. It forces all of us to confront a really uncomfortable reality. Are these ambitious, incredibly risky, and potentially damaging geoengineering plans a dangerous distraction? Or are they a necessary last resort in a world that's just not moving fast enough to solve the root problem?